morning, everyone. We are here to present our project titled Blockchain-Based Check Verification and Clearance System. The main problem with the current check process is that verification and clearance are manual, slow, and prone to fraud. Paper checks can be lost or faked, and banks take several days for processing. Our objective is to build a secure, transparent, and automated system using blockchain, where every check transaction is stored on a tamper-proof ledger and can be verified instantly by the user and bank. Now, let me briefly explain our system architecture. So this is our front-end page, a web interface for users and banks. And this is the Solidity code for backend. And this is the Ganesha we used, local Ethereum to test networks. And we also used MetaMask extension. Here are our main pages where home page where both user and bank can log in or sign up. And user can generate checks and view their status, where bank can view pending checks and clear them. In short, our project automates the check process on blockchain. Now my teammate will show how a new user signs up, logs in, and generates a check using MetaMask.
The user side of application. First, the user goes up to the sign up page and enters the basic details. Once registered, the user can log in using the MetaMask wallet. MetaMask acts as a digital wallet. It connects our decentralized application to the blockchain network. Now we'll be going to the sign up and we'll be entering our basic details. Now once we sign up, we'll get a message that successfully signed up. Next, we'll be doing the user generation part. After logging in, the user can click the generate check and fill in check details such as receiver, amount, and date. When the user clicks submit, MetaMask will pop up asking for confirmation of the transaction. On confirming, the check data is sent to the blockchain and Ganesh records the transaction in new block. The user can also click view status to check whether the check is pending or cleared. So this will complete the user side of check generation. Now we'll be seeing the user login part. So we'll be entering the registered login part and we'll be entering the bank name amount to be sent. Submit button, the MetaMask will pop up, and once we click confirm button here, in the Ganesh, a new block will be mined, 67th block. So this is with the user login part. Now the bank login part will be explained by Mahela. So now I'll be explaining about the bank login and check clearance process. So here, now in the user login page, we can see that the check has been in the pending status. So in the view status, the check has been in the pending status. And in the Ganesh, the check has been issued. So now the bank account will log in into the bank page. And here we have the view pending checks and clear checks. So in the view pending check, we can see that the check has been appeared here. And if the bank detail or if the bank verifies all the details, then we can click the clear option to clear the check. And now here the check has been cleared. The same thing we can see through the receiver's account. So here also the same check has been cleared. So now I'll be handing it over to Monique. So this is a Solidity smart contract is called check verification. It allows people to issue and later verify digital checks on the blockchain. Each check is stored as struct containing the issuer's address, the receiver's address, the amount, and whether it's been cleared. All checks are kept in a mapping called checks, and the total number is tracked by check count. When someone calls issue check, the contract increases the check count, creates a new check record with the sender as an issuer, emits an event check issued, so it's publicly logged on the blockchain. Events make it easy to track issued and clear checks transparently. Overall, this contract demonstrates how blockchain can record financial promises securely and traceably. On the front end, we use web3.js to connect the web interface with the contract using the ABI and contract address. MetaMask handles users' authentication and transaction signing. Our system enables transparent check verification. It eliminates manual errors and frauds. Every transaction is immutable and traceable. We can deploy this on a blockchain like Ethereum and integrate with real banking APIs. So this is our deployed smart contract. So this is a smart contract address and the name is check verification. So now Pooja will continue about the Ganache. 1 second please.
Now I'll show what happens in Ganache, our local blockchain network. Here you can see that a new block has been added each time we generate a check. If we open the transactions tab, we can see the transaction details. Function names like generate check along with the sender and receiver's address can be seen. Ganache also displays gas used, which represents the computational cost of executing the smart contract. In the events section, we can see logs like check generated and checks issued. These events help us trace every step on the blockchain transparently. This shows how our application interacts directly with the Ethereum blockchain environment through Ganache.